This question is from the 2012 higher level paper, Conic Sections, section B1. The convention centre shown in the image on the right is a landmark building in Dublin. Stunning design includes a glass front in the form of a right cylinder which intersects the vertical front face of the building. So a right cylinder just means that it's not oblique. The base of it will be a perfect circle. Figure B1 shows the elevation and end view of part of the structure. It consists of a portion of a right cylinder with its axis inclined at 60 degrees to the horizontal plane. So it's tilted back at 60 degrees, a regular cylinder. As shown in the end view, the cylinder intersects the vertical front face of the building, producing elliptical curves as shown in the elevations. This is your ellipse shape here where it cuts in. Part A, draw the given end view, include the straight line elements on the surface of the cylinder as shown. So they want the end view to begin with. Part B, project the given elevation, showing all construction lines clearly. Use the given elements to establish points on the curves. And part C, locate the two focal points of the semi-elliptical curve ABC, which is the one at the bottom, and determine the centre of curvature for the point B, which is the point there at the top. Our scale is 1:100, so we need to divide each measurement by 100 millimeters. Okay, same as usual, we'll start off with our XY line across the middle of the page. I'm going to keep it quite low here, there's no plan view on this one, so we don't have to keep it too high on the page. Okay, so XY line to begin with. Now, I'm going to start off with my end view. Scale 1:100. I'll start off with this triangle on the bottom is all I can really do first to begin with. I know it's 3 meters high and the angle is 30 degrees. So I'll pick a starting point for the angle, say there. Draw a line at 30 degrees going up. I know the height is 3 meters, which is 30 millimeters. See where the two lines cross, that gives me that point. So I know that's the slope there at the bottom. Now, I'm told it's a right cylinder, so if this is 30 degrees, the angle going up must be 60. Because that angle there has to be 90 degrees when it's a right cylinder. Touches the ground at that point, so I can bring that point straight up. That gives me the top point there. So if I go back and look at my drawing, that line there goes up to the top point there at the very top, similar to what I'm after drawing there on the page. I can bring that line down at 30 degrees. Now, we're given lines on the surface here, so 2 meters across and then 1.5. That gives me that point and that point, 2 points on that bottom surface, and I'm going to use those construction lines now. So if I just leave the sheet there, you might see it a bit better. If I draw up those construction lines to the top, that one, if you see from the sheet there, hits the point which is there. No, sorry, this one in between there, it's a different one. That one goes to the top. That tells me the cutoff point is there for that. So I can put a point there and draw the line straight across. So I know the width now of that back wall. I can draw that in. They give you a very limited amount of information in the question, so can you figure out exactly how to draw it. So that's the back wall, and I'm told then that this line goes from that corner down to the bottom, so I can draw another straight line element now on the surface there. Down there, the last part it shows there's hidden detail out here on the side. I'm just going to draw it in really lightly. I don't think that's necessary for the question. So just fill in heavy then the outline of the building. Okay, that's as much of the end view as we can do now. Moving on to your front elevation, I'm going to bring my construction lines across. I'll leave a distance there, that comes out 20, so I'll go over about 30 millimeters just so that they don't hit. I'll draw the back wall to begin with. So the full width is 18 meters, which would be 180 millimeters. Okay, that's the two sides finished. Now, we're told that points A and C are in 3 meters from each end, and it's 12 meters then left. So the major axis of that ellipse will be 12 meters. So I'll get those measurements first. So measuring 30 millimeters from each end. So I know that's going to be the major axis. I'm only dealing with half an ellipse here in the questions. We don't need to draw the full ellipse, we'll just draw half. Let's get the center point. Set my compass on the center point. I'm going to draw the major axis of the ellipse there to begin with. And I'm going to keep the construction of the ellipse quite light because it's only construction, it'll not be the finished piece. Now, what is the minor axis for the ellipse? So if you go back to the question here, it shows that the full height there is 3 meters up. So if you go back over, the height of B then must be 3 meters from the ground. So that would be your minor axis for your ellipse. That will give me point B. I'll draw in the minor axis. Again, I'm only going to draw half because we're only drawing half the ellipse. Keep it light, it's only construction. Okay, to draw in the ellipse, usual method then, I'm going to divide it up with my 60-30 set square into 6 equal spaces. I'm going to use the circle method to draw it. Try and get it as one continuous line joining up the dots. Okay, that'll be the ellipse now at the bottom, finished. So the top ellipse will be the same here, but before I do that, I want to find this shape here, and I'm going to use these elements now to find that shape. So I can bring these lines across to my ellipse now. So I know that's going to hit my ellipse at that point and that point. And I can bring those points straight up then. So I'm going to call these 1, 2, and 3. So those 2 points are 1. The height of 1 is there. I'm going to bring 1 across and see where it cuts those lines. That gives me a point there and there. Now, second one is line 2, so 2 across to the ellipse, which gives me 2 points there and there. I'll bring those straight up in front elevation. 2 finishes at that point in the end view, so I can bring that straight across. And I know it cuts line 2 at that point and that point. Lastly then we've 3. Bring 3 across to the surface of the ellipse, which is there and there. Bring those points straight up. Bring it straight across then from the end view. I know it stops at that point and at that point. Now, if you think this is too big of a space here, you can always take another line on the surface there, just for accuracy. Bring my line up like that. Bring it straight across. Gives me 2 points on the surface of the ellipse. And bring them straight up. Just as quite a large distance there, it might be better to do 1 for accuracy. You could probably still get full marks in the exam by not bothering with this one. But just to get the lines right, it might be a good idea. Okay, just join the dots then. That will give you that elliptical shape. Down to the bottom there, and then to get the one on the top, should be the top of the sloping cylinder. It'll be an exact replica of this one here, and I know that it has to go up to a maximum height of that. So probably the easiest way is to just translate it up with your compass. So the points on the ellipse are that one, bring those lines up. That was a point on my ellipse, so was that one. And then if I translate it up, so B at its full height goes up to that point there, so that's the max height. So if I move it down now, any of these points on the ellipse, that must be another point on the top ellipse. I can also do 3 there as well. 2, that point, and 1 will go back down to there. Same on this side. All the points that touch, you can just translate them up. Probably don't need them all, but I'll bring them all up anyway. It's just an exact translation up to the top. And then I can draw in that curved shape just by joining up the dots. Okay, and that would be the top of the sloped cylindrical part of the building. Okay, that's your front elevation finished. So that's part A and B completed now in the question. Part C, locate the 2 focal points of the semi-elliptical curve ABC, which is the one on the bottom, and determine the center of curvature for the point B. Point B is the one on the top there. So to locate the 2 focal points, it's the same method as we did before. Set your compass from the center point to the outside there. Move your compass up to B, which is in the minor axis, and mark your 2 points on each side. Those 2 points is F1 and F2, your 2 focal points. So very easy marks to get there in the question, F1 and F2. Then the last part is determine the center of curvature for the point B. Now the center of curvature means the center point where I'm supposed to set my compass to draw a section or a portion of the curve accurately there. So I need to find where the point of my compass should be. So to do that, there's a method for this. So join B to either F1 or F2, doesn't matter which one you join it to. This line here, normally we do a tangent at the point, but a tangent at point B would just be a horizontal line. The normal to the tangent will just be the perpendicular line, which is this axis coming down to the bottom. So I join B to F1, and then I go perpendicular from that line from the point F1. And that point now at the bottom of the page there, you can just about see it on the screen, that is my center of curvature for the point B. So if I were to set my compass on that point, set the distance up to B, it would draw accurately a small portion of the curve there. The important thing to remember there is that that angle is 90 degrees. And that would be part C of the question complete. You found your two focal points, you've determined your point of curvature for B, and that'll be the question completely finished.